So today we are going to learn binary search algorithm. So binary search is an efficient algorithm for finding a target value within a sorted list. It works by repeatedly dividing the search area into half. If the middle element matches the target, the search is successful. Otherwise, search continues either the left or the right half of the list, depending on whether the target is smaller or larger than the middle element. So this process is repeated until the target is found or the search interval is empty. So binary search is an efficient algorithm for finding a target value within a sorted list. So two things you have to keep in mind. We can apply binary search algorithm when our searching area is in a sorted manner. So we'll understand this by an example. So here we have an array of list. How many elements we have? 0, 1, 2, 3, 4, 5. And our target is 9. So first we are going to consider low is equals to 0, high is equals to 5, and mid is going to be low plus high by 2, which is 0 plus 5 by 2, which is going to be 2.5, approximately 2. So we got our mid at 2. So this is our mid. Now you are going to see, is my target equals to mid? Is my target greater than mid? So if your target is greater than mid, you can cancel the previous searching area and your new searching area will become mid plus 1 till half. So your low will become mid plus 1. So instead of searching in the entire search area, it is going to split into half depending on your target. So right now your low is 3, your high is 5. So your mid is going to be 5 plus 3 by 2, which is 4. Now, is your mid equals to target? Yes. Is your mid equals to target? Yes. So see, we have searched our element only in 2 runs. If I had to search target using brute force solution, what would I have done? I would have checked the list like is if I had to find 9 target without using simple brute force solution, then how would I find out? I would have searched from starting to end. I would have checked this. I would have iterated this entire array and say, if -1 equals to 9, no. Is 0 equals to 9? No. Is 3 equals to 9? No. Is 5? No. Is 9 equals to 9? So at 4th run, I would have gotten my target. But with the help of binary search, only at 2nd attempt I got the target. So this is a difference between using brute force and binary search. So first thing you need to understand, binary search happens only when it is sorted. Only when your item is in a sorted manner. Binary search will always have a what you call time complexity of log 2 of n. Because if suppose I have how many numbers? 1, 2, 3. If suppose I have 8 numbers, let's assume. So at first I'll search the entire 8. After that it will become 4. After then it will become 2. And finally we will receive the answer, right? In the same manner, if suppose I have 16, again it will become 8, again it will become 4, again it will become 2, and then 1. So it is getting pruned with half. That is the reason our time complexity is log n by 2. Because if you know log, if I write log, suppose 16 by 2, I could write log 16 by 2 as log 2 raised to 4 by 2, which is again going to be giving me 4. So in 4 steps, approximately I'm getting my response. You will see. Right, 1, 2, 3, 4. Same with here 8. If I write log 2 raised to 3, so in 3 steps I'm getting my answer. इसीलिए we are writing log n by 2. अगर यहाँ पे it is approximately going to take log n base 2 time complexity only, or you could say less than it, not more than that. Correct? I can go half. Either I'll get my response in this half, or at max I'm going to get in this half. That's it. Now let us solve one more example. Here our target is 2, which is of course not available. Minus 0, 3, 0, 3, 5, 9, 12. Same search area, same element, but now the target is 2. So my low first will be 0, high will be 5, mid will again come to 2. So is my target equals to mid? No. Is my target greater than mid? No. Is my target less than mid? Yes. Then my high will become mid minus 1. So low will remain in the same place. My high will become mid minus 1, which is 2 minus 1. So high will become 1. So my search space will become 0 to 1. Again, my low will become 0, my high will become 1, and my mid will become 0 plus 1 by 2. Let's just say 0. Now we will see, is minus 1, is my target equals to minus 1? No. Is my target greater than minus 1? Yes. So my high will become mid plus 1. My low will become mid plus 1. That means my low is going to be 1 and my high is also going to be 1. So is target equals to 0? No. Is my target less than 0? Is my target greater than 0? Yes. So my low will become mid plus 1 again, which is 2. And my high will still remain 1. Now low has become greater than 1. लो क्या हो गया अभी, मेरा जो हाई है उससे बड़ा हो गया, which is not, it makes no sense at all. My low has become greater than high. If this case arrives, you need to understand that there is no element present in our search area, and hence we will return minus 1. So you have seen, we tried, we did the math. At first we found mid at 2. We didn't get our target value. Then we find mid at 0. We didn't get our target value. Then again we found our mid at 1. We didn't get our target value. Same way, then my low become greater than my high. And we understood that there is no element present in our search area. Hence it become minus 1. There is one more case that I wanted to explain. First is, this is an array, correct? And the size of an array can be 10 raised to 5, 10 raised to 6, 10 raised to 7. Not greater than this. So our last element. Let's say we have an array and we have our last element as int max. Correct? So when you're going to find, and suppose we did binary search till last and we still didn't get our target value. At last, what will be remaining would be int max plus what is going to be your int max. Again, it is going to be, see, we have arrived situation where we have to add both same number at later stage. If you have seen the last example, so there could be cases where I had to do int max plus int max, right? And then I have to do 2. So this becomes a case of overflow, where I reach that situation in binary search where my variable is not capable of storing the number because I have the maximum number at last and I had to add those maximum numbers. So it becomes 2 times the maximum number. So to get rid of these issue, what we do basically is low plus high minus low divided by 2. This is nothing but low plus high by 2 only. But then you have to be very sure that your element lies between the search area. If you're very sure that your element lies in the search area, then you could write low plus high minus low divided by 2. So instead of getting variable 2 times, you're just going to get what? You're just going to get half of it. If my element is 25, so instead of getting like 25 plus 25, something like that, you'll get 25 minus 20, which is better, right? Then divide by 2 and here you're going to have 25. So this is very simple. This was one case of overflow. But if you're not sure that you have your element in a search area, so at that time you could make your low and high as long instead of end.